All right, strap yourselves in, folks, because today we are going supersonic.
We are.
We're diving deep into Boom Supersonic.
Oh, cool.
You know that company trying to bring back super fast passenger flights?
Like way faster than sound.
Right, exactly. Like crossing the ocean in the blink of an eye. We've got a ton of their press releases, blog posts.
I love those.
And even some summaries from their test flights. What I really want to know is how close are they to actually pulling this off?
Yeah.
And what is the deal with this boomless cruise?
Yeah, that's a good question. What I find interesting is that they seem to be putting their money where their mouth is.
Right.
Remember Concorde?
Oh, yeah, of course.
That supersonic jet zoomed across the Atlantic in under 4 hours.
Incredible.
It was an amazing feat of engineering, but ultimately it was grounded.
Right.
Issues like that sonic boom, fuel costs, limited routes. So Boom Supersonic is trying to pick up where Concorde left off, but with a new approach.
A new and improved approach.
Okay.
So how are they going about this? What's the strategy?
Well, they've got two main projects in the works. First, you've got the XP-1, their experimental aircraft.
Okay.
It's basically a scaled-down prototype, 1/3 the size of the actual passenger plane.
Gotcha.
It's where they're testing all their new technology. And then there's Overture.
Okay.
That's the planned commercial airliner.
The big one.
Yeah, that's designed to carry like 65 to 80 passengers.
Wow.
And that's the one that's supposed to, revolutionize air travel as we know it.
Okay. So XB1, that's like the proving ground for all the crazy ideas
Exactly.
before they scale it up to Overture.
Exactly. And one of the things they've been doing is really cool.
Okay.
It's a progressive testing approach.
What does that mean?
So instead of just like, all right, let's hit supersonic right out of the gate,
Right.
they've been slowly increasing the XB-1's speed and altitude with each test flight.
Okay.
It's almost like, leveling up in a video game.
I like that.
Methodical. Right?
Totally. They're making sure that everything's working perfectly before pushing it further. They don't want to break anything.
No, they don't want to break anything. And these tests aren't your average, like, let's just take it for a spin. It's very detailed.
Oh, wow.
They did something called flutter testing.
Okay.
They used this special vibration device. It's called the Flutter Excitation System.
Catchy.
Yeah. To make sure the plane could handle the intense vibrations at high speeds. And get this, they even tested how the XB-1 handled with its stability system turned off.
Oh, really?
Yeah. Just to see what would happen, like worst case scenario.
Like if it fails?
Yeah, if it fails, what happens?
Wow. Talk about being thorough. So they really want to make sure that this thing is bulletproof before it carries passengers.
For sure.
What else did they test?
They put the plane through these crazy G-force tests.
Oh, wow.
To make sure it could handle those sharp turns at supersonic speeds.
I can't even imagine what that would feel like.
Yeah.
So what else?
But here's where it gets really interesting. They're even testing a special coating inspired by shark skin.
Wait, shark skin?
Yeah.
Shark skin on a plane?
What? How does that even work?
So it turns out the texture of shark skin reduces friction in the water.
Okay.
So Boom is trying to apply that same principle to their aircraft to reduce drag and make it more fuel efficient.
Ah, clever.
Imagine if this could mean, like, cheaper ticket prices for you down the line.
Right. That'd be amazing. I love how they're looking at nature for inspiration.
Nature's got a lot to teach us.
Yeah, exactly. So all of this testing led up to the big moment, right?
The big one.
The supersonic flight.
Yeah.
Did it happen?
It happened January 28th, 2025.
Okay.
The XB-1 broke the sound barrier.
Finally.
Not just once, 3 times in a single flight.
What?
And get this, they did it in the same airspace where Chuck Yeager first broke the sound barrier back in 1947.
No way. Talk about historical significance.
That's pretty cool, right?
That must have been a huge moment for them. Breaking the sound barrier is one thing.
Right.
But doing it 3 times.
Yeah.
And in the same spot as Chuck Yeager.
That's like a giant leap forward. What does this mean for Boom moving forward?
Well, it's a big milestone. It was the first time a civilian supersonic jet designed in the U.S. has flown since Concorde.
Wow.
And it sets the stage for their next challenge, boomless cruise.
Okay.
Yeah.
Let's talk about boomless cruise.
All right.
What is it? It sounds a little bit magical.
A little bit magical.
Yeah.
Well, it's less magic, more physics. They announced boomless cruise on February 10th.
Okay.
Just a couple weeks after their supersonic flight. It all comes down to Mach cutoff.
Mach cutoff. Okay. That sounds very technical.
It sounds technical, but it's actually pretty simple.
Okay.
Think of it this way. You throw a pebble into a pond, right?
Yeah.
It creates ripples.
Yeah.
But what if the pond was super deep?
Ugh.
Those ripples might not reach the edge.
Right.
Mach cutoff is based on that same idea. A sonic boom created high enough in the atmosphere doesn't reach the ground. The XB1 data confirmed they could fly supersonically without that window-rattling boom on the ground.
So the higher they fly, the less of a boom.
Pretty much.
It's a pretty simple solution, right?
Mm-hmm.
How does this affect Overture, the passenger plane?
Well, Overture's plan to fly at Mach 1.3 over land.
Okay.
That's about 50% faster than today's jets. Using this boomless cruise tech, they'll only go full speed, Mach 1.7, over water where the sonic boom isn't a problem.
So faster flights over land without disturbing everyone below, that's a win-win.
I think so.
But how are they going to achieve these incredible speeds? What kind of engine are we talking about here?
That brings us to Symphony, the heart of Overture. It's not your average jet engine.
I imagine not.
It's custom designed for supersonic flight and reaching those high altitudes needed for boomless cruise.
And when will we see that?
Well, they're aiming to have full engine core tests done by the end of 2025.
Full engine core tests.
Yeah.
Okay. What exactly are they testing? What's so special about this Symphony engine? That sounds like a conversation for part 2 of this deep dive. Hashtag TTS, the deep dive episode 2025-0210, part 2 of 3.
So this Symphony engine,
Yeah, let's dive into that.
Boom knew they couldn't just slap any old engine on Overture.
Right.
They needed something that could get it to those crazy Mach speeds,
Yeah.
but it also had to be efficient and quiet enough for boomless cruise.
Right, because fuel efficiency is a big deal.
Huge deal, yeah.
And noise pollution.
Exactly.
Yeah.
So they decided to build an entirely new engine.
Wow, from scratch.
Yeah.
Why not just modify an existing one?
Well, think of it this way. Modifying an existing engine is kind of like trying to turn a bicycle into a race car.
Okay,
You might get it moving, but it's not going to perform the way you want it to.
makes sense.
Symphony is what we call a clean sheet design,
Oh,
meaning every component is built for supersonic flight from the ground up.
that's impressive.
Yeah, and that's why those full engine core tests they're planning are so important.
Yeah, you mentioned engine core tests. What exactly are they testing when they test the core?
So the core is like the heart of the engine.
Okay.
Imagine looking inside. You've
Yeah.
got the compressor,
Okay.
which sucks in air and squeezes it. Then there's the combustor,
Combustor.
where fuel mixes with that compressed air and ignites.
Yeah.
And then you've got the turbine, which uses the energy from the burning fuel to power the whole thing.
Right.
So testing the core means making sure all these parts can work together perfectly under extreme conditions.
Right. The extreme conditions of supersonic flight.
Exactly.
So much could go wrong.
Yeah.
What are some of the challenges they're facing?
Well, heat is a big one.
Right, because of the friction.
Exactly. At supersonic speeds, the engine gets incredibly hot. So they have to make sure that the materials can take it.
Right, and not melt.
Yeah, basically. They also have to make sure the fuel burns cleanly
Right.
and efficiently, so they're not wasting energy or polluting like crazy.
Of course, the environmental impact.
And of course, reliability is key. Can you imagine an engine failure halfway across the Atlantic on a supersonic jet?
No, thank you.
Not a good time.
Yeah. So this engine is critical.
It's everything.
And they didn't just go it alone, right? They teamed up with other companies for Symphony.
Oh yeah, Boom realized they couldn't do this all by themselves.
Smart.
So they brought in some of the best in the business.
Oh, who did they bring in?
They're working with Florida Turbine Technologies. They're known for their high-performance turbines.
Okay.
They've also got Calibrium Additive. They specialize in 3D printing for aerospace parts.
Wow, that's cool.
Yeah, it is cool. And then there's Standard Aero.
I've heard of them.
Yeah, they're leaders in aircraft engine maintenance and repair.
So they've got all their bases covered.
That's the gold.
Power, cutting-edge tech, reliability.
You're ticking all the boxes.
It seems like a really smart strategy.
It is.
Bringing in these partners not only gives them the expertise,
Right.
but also it makes the project more credible.
Pull
It
it.
shows they're serious.
Yeah, they're not messing around.
It's fascinating to see how it's all coming together.
It is, right.
But let's step back for a second. We've talked about XB1, boomless cruise, the Symphony engine.
Yeah.
What does this mean for aviation in general? Are we really about to see a supersonic revolution?
That's the million-dollar question. It's probably too early to say for sure.
Yeah.
But there's definitely a lot of potential
All right.
if Boom can pull this off, and that's a big if.
Yeah, big if.
We could be looking at a future where supersonic travel isn't just for the super rich.
Right.
It could be something that everyone can experience.
Wow, that's a big deal.
Yeah.
What kind of impact would that have on the world? Aside from just getting places faster, I mean.
Oh, the implications are huge. Think about business travel. Imagine flying from New York to London for a meeting and being back home the same day.
Yeah, no more jet lag.
Yeah. That would completely change international business.
Right. Deals, collaborations, relationships would change everything for people who travel a lot for work.
Yeah. But there's an environmental impact to consider.
Right.
Burning all that fuel to go supersonic can't be good for the planet.
Yeah, that's a valid concern. Is there a way around that?
Well, supersonic flight does burn more fuel than your average subsonic flight.
Right.
But Boom claims that Overture will run on 100% sustainable aviation fuel.
Okay.
Which is a good thing.
Yeah.
And remember that shark skin technology.
Oh, right.
That could make a big difference in fuel efficiency, too.
Yeah, I hope so. But what about cost?
Yeah.
Will supersonic flights ever be affordable for everyday people?
Right.
Or will it always be a luxury?
That's a tough one. At first, supersonic tickets will probably be expensive.
Yeah, like Concorde.
Exactly. But as technology improves and they get more efficient, the cost could come down.
Okay.
It's possible that in the future, supersonic flights could be as affordable as, maybe not budget airlines, but definitely like business class today.
That would be amazing.
It would. It's exciting to think about.
It's exciting. But this is a pretty ambitious undertaking.
Yeah, it is.
What are some of the biggest challenges they still have to overcome?
Well, regulation is a big one.
In what way?
Flying supersonic over land is still banned in a lot of countries.
Right, because of the noise from the sonic boom.
Exactly. Boomless cruise tech could be the answer.
Right.
But they still have to convince regulators around the world that it's safe.
That makes sense.
And then they also have to build all the infrastructure to support these supersonic flights.
Like what?
I'm talking about specialized airports, air traffic control systems, maintenance facilities.
Oh, wow. So it's not just about the plane itself.
No, it's a whole ecosystem.
They've got a lot of work ahead of them.
They do. And then, of course, there's the funding.
Yeah, I was just thinking about that.
Building a supersonic airliner is super expensive.
I can't even imagine.
They have some funding, but they'll need a lot more.
Right. To get this thing off the ground. Literally. So many hurdles. But it's inspiring to see how far they've come.
Absolutely.
It really feels like we could be on the brink of a new era.
It does. It's an exciting time to be following this.
It is. It's a story of ambition, innovation, pushing the limits.
Absolutely.
And let's not forget, Boom Supersonic is just one part of a much bigger conversation.
Right.
About the future of aviation.
There are other companies out there exploring supersonic and even hypersonic travel.
Hypersonic. Okay, now that's getting really futuristic.
Yeah.
Maybe we'll do another deep dive on that sometime.
Maybe we will.
But for now, let's stick with Boom and their quest to bring back supersonic passenger travel.
Sounds good.
We were talking about boomless cruise and how it's supposed to reduce those sonic booms.
Right.
Can you explain the science behind that a little bit more? Hashtag TTS, the deep dive episode, 2025's O210, part 3 of 3. Okay, so we're back to boomless cruise. This technology is supposed to solve the sonic boom problem, one of the main reasons the Concorde was grounded, right? Can you remind me again what a sonic boom is?
Sure.
And why it's such a big deal?
So imagine a speedboat
Okay.
zipping across a lake. It creates a wake behind it.
Yeah.
A sonic boom is kind of like that, but instead of water, it's a shockwave. Created when something, like a plane, travels faster than the speed of sound.
Right.
That shockwave can travel for miles.
Wow.
And when it hits the ground, it's like this super loud thunderclap.
Yeah, I can imagine.
Yeah, not something you want over a city.
Right, definitely not. So how does flying higher help with that?
It's all about how sound waves travel in the atmosphere.
Okay.
As those shock waves travel down from the plane, they hit different layers of air
Right.
with different temperatures and densities.
Mm-hmm.
And those changes cause the waves to refract, which means they bend.
Like light through a prism.
Exactly. So instead of hitting the ground directly,
Yeah.
the sound waves get bent away.
Okay.
And if the plane is high enough,
yeah.
those shock waves will actually bend upward.
Away from the ground.
Away from the ground.
That's pretty amazing.
And they dissipate before they reach us.
So the sonic boom doesn't go away completely. It's just
Yeah.
redirected. Smart. But how high are we talking here? Do they have to go into space for this to work?
Not quite space,
Okay.
but pretty high. Based on their tests with the XB1,
Right.
Boom thinks Overture can pull off boomless cruise at altitudes above 50,000 feet.
Wow, that's higher than most planes fly.
Yeah, it's higher than most commercial airliners, but it's totally doable.
Okay, so they're basically flying above the problem.
Yeah, that's one way to look at it.
I'm sure there are some people out there who are still a little skeptical.
There's always skeptics.
How is Boom addressing those concerns?
Well, for starters, they're being really open with their research and data.
That's good.
They've published a ton of reports on the science behind boomless cruise.
Okay.
And they're talking to experts in the field, getting feedback.
Makes sense.
And they're not rushing the testing either. All those rigorous tests we talked about,
Right.
that's to build confidence in the technology.
To prove that it's safe.
Exactly.
And of course, they have those big partners on board.
Oh, yeah, that definitely helps.
Adds a lot of credibility.
Absolutely.
So-
Working with companies like Florida Turbine Technologies and Standard Aero Shows, they're serious.
Yeah, they're not messing around.
Nope.
This has been really fascinating.
Yeah, it's cool stuff.
But what does it all mean for us, the potential passengers?
Right.
Will we actually be able to book a supersonic flight on Overture anytime soon?
Well, it's exciting to imagine.
Yeah, sipping champagne at Mach 1.3.
Right. But it's important to remember that this is still a long way off.
Okay,
They still need to finish designing Overture,
right.
finish the symphony engine, get all the approvals, build all the infrastructure.
It's a huge project.
It's massive.
So we're not going to be looking tickets next week.
Probably not.
But it sounds like they're moving in the right direction.
They are. They're making progress. It'll probably be another decade or so before we see commercial supersonic flights become like a normal thing.
Wow, a decade.
Yeah,
But the progress they've made is definitely encouraging.
it is.
Well, I'm going to be watching this closely.
Me too.
It's not every day you see a potential revolution in air travel happening right before your eyes.
It's a really fascinating story, you know?
Yeah,
It speaks to that human desire to push boundaries.
to explore.
Yeah. Who knows, maybe one day supersonic flight will be as normal as taking a train?
I can't even imagine. Thanks for taking us on this deep dive today.
Absolutely. It was my pleasure.
It's given me a lot to think about.
And for all you listeners out there, keep dreaming big.
Yeah, don't stop dreaming.
The future of travel is going to be pretty wild.
It's going to be amazing.
Thanks for listening, everybody.